All right, so now we're going to take a look at evaluating limits of two variable functions, this time using a table. So I have a Google Doc open, and we're looking at the function that we looked at before. It's the function f of xy equals y squared divided by parentheses x squared plus y squared. And we're going to evaluate this as our point xy goes to the point 0, 0. So to do this, I'm going to enter my x values along the top here, and I'm going to enter them starting from -1 to 1 in increments of a tenth. And I can use my spreadsheet feature to click and drag and automatically fill those in. Let's highlight our x values in green and label these along the top. These are our x values. And then we're going to do the same thing with our y values, going from -1 to about 1 in increments of a tenth. Obviously, if you wanted more accuracy, you could go in finer values and finer increments if you wanted, and you could change where you're looking. Because we want to go to the point 0, 0, that's why I'm looking somewhere between -1 and 1. And let's label these as the y values. Whoops. Use. So next, we're going to use these xy values and input them into our formula. So recall, our formula is y squared divided by x squared plus y squared. In this case, my y values are over here on the left, so I'm going to highlight this cell. B3 is my y value, and I want that squared. And then I divide it by my x value, which is C2 squared plus B3 squared. And I'm using the cell names because now I have the capability of being able to drag this to fill in the rest of the table. It turns out that if I just click and drag like this, it doesn't actually give me the values that I want. I want them to be fixed. Oh, my computer is going a little slow. I want them to be fixed so that, for example, if I were to look at the cell right here, I would want my x value to be this green value up here. And it turns out in this formula, my formula is displayed right here. My x value is I6, and I actually would want it to be I2. So that doesn't work the way that I want it to. How can I get this click and drag to work? I'm going to undo and undo. To make this work, I'm going to have to freeze some of the cells. I know that my B row needs to align with my B row every single time. So I'm going to add a $sign in front of my B3 both times. And that'll fix my row so that it always aligns with the same row. And then for my x value, I always want the column 2 to line up. So I'm going to fix it that way. If you don't know or forget, you can experiment where you put these $signs to make it work. But now, when I click and drag, it turns out the values in my table are exactly what I expect them to be, that my x values and y values align. So let's fill in this table and see what we get. Look at this. So now, when I look at this set of values, this is telling me that, for example, when I plug in a y value of 0, it doesn't matter what my x value is, I'm always getting a value of 0 out. And that's what's represented by the fact that whenever my y value is 0, I have zeros along here. Except, right at the point 0, 0. We knew that from before, that when I plug 0, 0 into my function, I get an undefined result. I'm dividing by 0, and my spreadsheet tells me that. However, look, when I have my x value equal to 0, I always get a value of 1, because that's just y squared divided by y squared, which is always going to be 1, except when both x and y are 0. And so we can see that as I approach along the y's, I'm always at 0. As I approach along the x's, I'm always at 1. And you can also see some interesting patterns. As I approach along the line y equals x, that's given by this diagonal. It's difficult to highlight the diagonal. Maybe I can highlight some of the squares in the diagonal. But along this diagonal, we see that we're always at constant values of 0.5. That's telling us that as we approach, the point 0, 0 along this line, we have constant values of 0.5. And thus the limit must not exist, because as I approach from different directions along this line or this line or this line, it's giving me different values. Let's evaluate this a second time using instead a grapher. So I'm going to go to wolfram-alpha. This is wolfram-alpha, and we're going to plug in our function f of xy. And this case was equal to y squared divided by x squared plus y squared. Enter. And wolfram-alpha thinks a little bit, and it's going to turn out a picture for us. So the picture that we get, this is the picture of their plot, and as you see, it sort of looks like a sheet that's been pinched. As I approach along these values, as x is 0, 0, I have my y values up at the value, or my z values are up at the value 1, whereas when my y value is 0, I'm down here along at the value 0, and right at 0, 0, it's like we have this vertical cusp, and that's exactly represented by our contour plot down here. That as I approach along this line, where my y values are constantly equal to 0, I'm down at 0. When my x values are constantly equal to 0, I'm up here at 1. And you can even see the line y equals x, which is this line along here, is also along a flat contour line of 0.5. So those are two different ways to visualize limits of two variable functions, either using a table or using graphs.